tonight in preparation for paper 3. Going to record them in chunks, so this is the first 4 questions, and we'll do our best. So, first question we are looking at is to do with inequalities, and it's to do with number lines. So, what the first question asks us to do is ask us to show on the number line -2 less than or equal to x less than 3. Now look, from the point of view of x, this means that it is greater than or equal to -2. So it starts at -2. It goes up to, but not including 3. So the first thing to do is to put the circles at the numbers. At -2, we put a circle. At +3, we put a circle. Now the x is between those two values, so we connect it. And then we need to be very careful. For the -2, it says greater than or equal to. Because it's allowed to be equal to -2, this is coloured in. At the other end, where it's 3, it says less than 3. It's not allowed to be 3, so this is left as an empty circle. Okay? If it's allowed to be equal to, it gets coloured in. If it's not allowed to be equal to, it's left empty. And that's an example of what that looks like. You'll see loads more on Maths Watch that I've set you to help you with different types of inequalities. Part B here asks us to solve an inequality. And remember, when you are solving inequalities, you imagine it was an equal sign and do what you would always do. So the first thing we do here is take the +3 over to the right-hand side where it becomes -3. So we get 5n is greater than 24. You now divide both sides by 5. So to divide both sides by 5 goes across, we get n is greater than 24 over 5. And that's absolutely fine to leave it as a final answer. No. So that's question 1, inequalities. Solving them and representing them on number lines. Question 2. It refers to an arithmetic sequence. Arithmetic sequences are linear sequences. They're going up by the same thing each time. It wants the nth term. So we look at the first difference, +6, +6, +6. That means that our nth term contains 6n because it's like the 6 times tables. If it was the 6 times tables, it would be going 6, 12, 18, 24, and we can see that ours doesn't do that. You have 2 choices here. You either look back at what the 0th term would be. In this case, it would be a +5. Or you could subtract your 6 times tables, and again, you'll find here that you get the constant 5. Depends which method you prefer. 6n is for all of us, but it's then a question of whether it's, do you look at the 0th term to find the 5, or do you subtract the 6 times tables to get the 5? Part B, is 121 a term in this sequence? Explain your answer. If it was, then you'd be able to take 6n plus 5 equals 121, and you would be able to solve that straight away. So, what do? We try and solve it. If we solve it, we get a whole number. It's in the sequence. So, how do we solve it? Same as before. Take 5 away from both sides. 6n equals 116. Divide both sides by 6. Now, if you get a whole number, then that tells you where it is in the sequence. If you don't get a whole number, it's not in the sequence. So 6 is into 116. 6 into 1 goes 0. 6 is into 11. Goes 1, remainder 5. 6 is into 56. Goes 9. Remainder 2. It does not divide exactly. And therefore, it doesn't work. It's not a term in the sequence. If the solution was a whole number, then yes, it would be. But it wasn't, so it's not. And that's how you test if it's in the sequence or not. On to question 3. Question 3 is the first 5 terms of an arithmetic sequence. Same again. Okay, so we can look really quickly here. It's going up in 7s, so it must be 7n. If you went back to the 0th term by taking away 7, you'd get -2. So this sequence is 7n minus 2. Part B of the question looks at a quadratic sequence. And the quadratic sequence says the expression 4n squared minus 5 is the nth term of a different sequence. Find the third term. To find the third term, you just see what happens when n equals 3. That means you replace the n here with 3. Now you know to put this in brackets when you replace it. So it's 4 lots of 3 squared minus 5. Now you could type that into a calculator. But of course, let's just make sure our bid mass is good. The first thing you do is the power. 3 squared is 9. This becomes 4 times 9 minus 5. In bid mass, we then do this multiplication before the subtraction. 4 nines is 36. And we're still taking away 5. And that gives us the final answer, 31. The crucial part there was knowing the third term. You merely substitute n equals 3, and then either use your calculator or use your brain, whichever is better for you. If it's a calculator paper, I'm using the calculator. Our final question of this section. Question 4. Tom and Amy set the alarms on their phones to sound at 6:45 a.m. Both alarms sound together at 6:45. Tom's alarm then sounds every 9 minutes and Amy's sounds every 12 minutes. At what time will both of the alarms sound together? Now what we're looking at here is a lowest common multiple question. It's every 9, it's every 12. You could do all sorts of crazy stuff with prime factors and Venn diagrams to work out the lowest common multiple. Or you could go old school and just list out 9, 18, 27, 36, 45, 54. We'll carry on if we need to. Then I could list out my 12s, 12, 24, 36, 48. Hang on a minute. The lowest common multiple of 9 and 12